Hello and welcome to Everyday Science. So there's a reason why I'm wearing these other than just to look so damn cool. Yes, I'm going to be talking about 3D glasses today, so if you have any anywhere around your house lying around that you don't mind popping the lenses out of, go pause the video, go get them and pop the lenses out. So not only are you a fully fledged tipster, but you can harness the powers of the physics in your very own hands. So what I want you to do if you do have lenses is put one out in front of another and copy off what I'm going to do. First of all, just to demonstrate I'm not cheating, I'm going to put these in front of the screen, the camera, and you can easily see that these are basically just normal lenses. They don't do anything special when you turn them around. And you'll see why I'm doing this in just a moment. So I'm going to stick one lens onto or over the camera lens. So you guys can see through it clearly, because I will put the other lens in front of it. Basically the same thing as just holding out one in front of the other, just so it's clear and right up to the camera screen. I can move this one about easily. So what I want you to do is put it up to it and move it around and look through them both. And you'll notice every 90 degrees it changes from being pretty much pitch black to light. And you'll notice this trend that carries on right the way through as you turn it around. So clearly turning around this lens in front of the other lens affects the amount of light passing through them both. So the trick is I lied, these aren't actually tinted lenses, these are polarizing lenses. And you may have noticed if you put one of them in front of like the computer screen or the television screen and turn it around, you get the same effect as putting the two lenses one behind another and moving them around. So what is actually going on and how does this apply to the cinema and 3D movies? So what is polarization? Well, to understand this we need to treat light as a wave, because of wave particle theory, and in particular we need to treat it as a transverse wave, which has a direction of motion this way. So if you think of it in a 3D plane, light can move in a bunch of different directions perpendicular to its line of motion, like all these and much more. And light emitted from the sun or natural light sources emits all of these directions. So this is unpolarized light, but then you put a polarized filter there, and out you get polarized light, a singular direction of light, because all the other directions are absorbed. So polarization is the isolating of a singular direction of a wave. So how does this all apply to you being at the cinema watching a 3D movie? Well, basically, this lens polarizes light in this way, so only light going this way can get through the lens, and light going that way is absorbed by the lens. And this lens only lets light going through that way and absorbs all light going through this way. So what you get is this lens letting light through that this lens doesn't let through, and this lens letting light through that this lens doesn't let through. And what happens at the cinema, they project two images onto the screen, so you'll see this if you take your 3D glasses off during a movie. And the two images are actually polarized. So one is this way and the other one's this way. So you get one image projected through this lens and the other image projected through this lens, and they actually are filmed at a slightly different perspective. So one image is actually at a slightly different perspective than the other, which actually is interpreted by your eyes. So basically it's the same as when you see things, because this eye is a slightly different place to this eye, so you get a slightly different perspective. So this gives you the whole idea of things being 3D, and your brain interprets the different perspective as being 3D. So thank you for watching my tutorial of how to be a hipster physicist, and I'll see you next time.